Okay, Assalamualaikum and hi everyone. So in this video we are going to continue discussion about revision for PSPM. Okay, so for question number 1, naturally occurring isotope of carbon consists of 4 isotope. So dekat sini kita ada carbon 11, carbon 12, carbon 13 and carbon 14. So the proton number of carbon is 6. So which of the following true about carbon isotope? Jadi dekat sini kita ada neutron. Okay, attractive force of carbon 14 nucleus is stronger than that of carbon 11. So this one is wrong. Okay, carbon 14 has the most neutron. So this one is okay, correct because untuk cari bilangan neutron is nucleon minus proton. Okay, which is 14 minus 6. Okay, so kita dapat 8. Okay, and the rest is 11 minus 6, 5, 12 minus 6, 6, then 13 minus 6 13 minus 6, 7. Okay, jadi jawapan dia adalah B. Okay, option number 2. All isotopes are having different atomic size. Salah. All carbon isotope contain same number of neutron and electron. So that one is wrong. Okay, then next. Okay, figure 1 shows the mass spectrum of bromine. If the average atomic mass of bromine is 79.049 AMU, calculate the percentage abundance of bromine 81. Jadi untuk bromine 81 kita assume, okay, kita letak di sini bromine 81 sebagai, okay, kita letakkan dia sebagai X, and then bromine 79 bromine 79 X, dan bromine 81 sebagai 100 minus X. Okay, alright. So substitute dekat dalam summation Kimiki. Okay, summation Qi Mi over summation Qi. Jadi 79, okay, 79 times X plus 81 times 100 minus X over 100 equal to 79.0904. Jadi kita dapat X is equal to 55. Okay, so BR81 is 100 minus X. Jadi 100 minus X, 100 minus 55 is 45. Okay, so the answer is B. Okay, question kedua. Alright, then question 3. Okay, Y2 molecules composed of Y atoms. If the ratio of the molecular mass of Y to carbon is 5.92, determine the relative atomic mass of an element Y. Jadi relative atomic mass dia, okay, ini adalah untuk atom. So dia bagi dekat sini, this one ratio molecular mass kepada carbon 12, 5.92. Jadi 5.92 equal to mass of molecule Y over 12. So mass of Y is equal to 5.92 times 12 equal to 71.04. So for this one is the mass of molecule Y2. Jadi kalau untuk molecule atom Y, okay, so 71.04 divided by 2 equal to 35.52. So the answer is option yang keempat. Okay, alright. Then question number 6. A sample of organic compound Q contain 40% of carbon, okay, 6.67 hydrogen and 53.33 oxygen by mass. Determine the empirical formula of the sample Q. Jadi kita gunakan table lah. Okay, so persen ini kita anggapkan sebagai mass. Okay, so 40, 6.67, 53.3. So divide by 12, okay, divide by 1, divide by 16. So kita dapat 3.33, 6.67 and 3.33. So the answer is, okay, simplest ratio is 3.33 over 3.33, 1, 6.67 over 3.33, 2, 3.33 over 3.33, 1. So the answer is CH2O. Okay, which is option yang ketiga lah. Okay, right. Next, calculate number of hydrogen atom in 9.6 gram of NH42CO3 compound. Jadi, okay, kat sini kita ada 9.6, okay, 9.6 over molar mass. Okay, molar mass untuk NH42CO3, so dapat 0.1. Jadi bilangan mol hidrogen ialah ada 8 atom hidrogen, 8 times 2, okay, 4 times 2, 8 so 8 times 0.1, 0.8. Jadi 0.8 times 6.02 exponent negative exponent 23, kita dapat 4.817 exponent 23. Jadi the answer is option yang kedua. Okay, next. A solution is made by dissolving 100 grams of sugar, okay, C12H22O11 in 250 gram of water. So calculate the molarity of the solution. Jadi kita kena kira bilangan mol dahulu. Jadi bilangan mol of sugar is 0.2924 over 100 over 342 equal to 0.2924 mol. Okay, dah dapat bilangan mol bagi dengan mass of solvent, okay, in kilogram. So kita dapat 1.17. So the answer is option yang keempat. Okay, next. You are given the density of nitric acid 1.11 gram per milliliter. Calculate the molarity. Okay, so daripada density, okay, daripada percentage by mass, okay, sorry this one is percentage by mass. Okay, this is percentage by mass, and then this is density. Okay, so assume, okay, the mass of solution is 100 grams. Jadi kalau mass of solution is 100 gram, jadi mass of solute is 19 grams. Jadi 19 over, okay, molar mass there is 1 plus 14 plus 48, 63 this one. So kita dapat 0.3016 mol. Jadi dapat bilangan mol. Okay, kita nak cari volume pula. Volume sama dengan, okay, mass over density. Jadi mass tadi kita dah assume 100 gram, di 100 over 1.11. So kita dapat 90.09 milliliter ataupun 0.09009 liter. Jadi dah dapat volume, kita dah ada bilangan mol, kita boleh cari molarity. So 0.3016 mol over 0.09009 liter. So kita dapat 3.35 molar. Okay, so the answer is option yang kedua. Okay, alright, question number 10. Sorry, question number 7. 0.45 mol of iron, okay, Fe react with 0.83 mol of water based on the chemical equation given. Which of the following substance is the limiting reactant? Jadi untuk tentukan limiting reactant, kita gunakan kaedah yang cepat, iaitu kita cari find the smallest ratio, okay, reactant kepada stoichiometric coefficient, iaitu 0.4 over 3, dan juga kita dapat 0.133, 0.83 over 4, so sama dengan 0.2075. Jadi yang paling kecil adalah Fe, ratio Fe. Jadi Fe is limiting reactant. Okay, alright, question 8. An electron transition from higher to lower energy level emits a photon with wavelength 1282 nanometer in Paschen series. Okay, so dia dah bagi lambda, dia sudah cari energy. Jadi lambda is delta E is equal to Hc over lambda. Jadi H kita 6.63 exponent negative 34 times 3 exponent 8 over lambda kita adalah 1282 exponent negative 9 nanometer. Jadi the answer is 1.55 exponent negative 19 joule, which is option yang kedua. Okay, question number 9. Okay, figure 2 shows the Balmer series of hydrogen emission spectrum. Calculate the wavelength that produce line C. Jadi untuk line C, ini adalah transition daripada, okay, kalau yang pertama, this one, transition daripada N sama dengan 3 pergi N sama dengan 2, N sama dengan 1 pergi N sama dengan, 4 pergi 2, and then 5 pergi 2. Jadi C ni adalah 5 dan 2. Digantikan saja dekat dalam formula 1 over lambda sama dengan RH. Okay, so for the lambda kita dapat 434 nanometer. So the answer is option yang pertama. Okay, question number 10. Calculate the ionization energy of hydrogen atom for Lyman series in kilojoule per mole. Given the Avogadro constant 6.02 exponent 23 mole. Okay, so first kita tahu kalau ionization energy untuk Lyman series, dia makes transition daripada 1 pergi infinity. Okay, jika 1 pergi infinity, Jadi kita substitute dekat dalam delta E, kita dapat delta E sama dengan 2.18 eksponen negatif 18 joule. Jadi untuk 1 mol of electron kita darabkan dengan Avogadro constant, so kita dapat 1313 kilojoule per mol. Okay, the answer actually dalam joule per mol, so ini saya dah tukar pergi kilojoule per mol, so dapat 1313 kilojoule per mol. Okay, right, next. Okay, so for question number 14, which of the following is the electron configuration of copper 29? So given the proton number for copper is 29, so the arrangement for copper is 1s2, 2s2, 2p6, so this one 10, 3s2, 3p6, 18, okay, and then plus 10, 29 plus 1. So fully filled 3D orbital. Okay, so this is the most stable arrangement. So the answer is option yang ketiga. Alright, and then question number 15. Which of the following Lewis structure is the most plausible structure of iodate IO4 minus? So given the proton number of iodine is 53 and oxygen is 8. So iodine is group 17, so it has a 7 valence electron, and then oxygen is group 16, so it has 6 valence electron. Okay, so when we have IO3, IO4 minus, meaning that 1 electron is added to the iodine, so iodine will have 8 electron configuration, 8 electron in the central atom. So this is the formal charge. Okay, formal charge is equal to number of valence electron minus number of electron surrounding the atom. Okay, so number of valence electron for iodine is 7, so 7 minus 1, 2, 3, 4, 5, sorry, number of valence electron for iodine, oxygen is 6, so 6 minus 7, negative 1, so this one 0, negative 1, 0, so this one the formal charge is positive 2. Okay, 6 minus, sorry, this one 6 minus 1, 2, 3, 4, 5. Okay, so 6 minus 5 is positive 1. Okay, and then negative 1, negative 1, negative 1, positive 1. So this one is 6 minus 6, 0, 6 minus 6, 0, 6 minus 6, 0, 6 minus 7, negative 1. Then this one is negative 1, negative 1, 0. Okay, so this one is 1, 2, 3, 4, 5. So this one is actually 5 minus 6 minus 5, positive 1. Okay, so the most plausible is structure C, because structure C satu saja yang ada negative 1. Okay, it bear the lowest formal charge. Okay, right, so question number 16. Choose a question number 13. Choose a correct statement why sulfur can form more than one compound compared to oxygen upon reaction with group 17 element respectively. So even though both are in group 16, so sulfur group 16, okay, oxygen pun group 16, so it has 6 valence electron, this one also 6 valence electron. So the difference, okay, sulfur has 6 valence electron, tak boleh, because oxygen also have 6 valence electron. Oxygen is an incomplete octet atom, tak boleh. Oxygen is the most electronegative element, so this one also wrong. So the most correct answer is sulfur has an available empty d orbital. Okay, because it is in period 3. Okay, sulfur is in period 3, jadi dia ada empty d orbital. Okay, so which of the following statement is correct about I3 minus and N3 minus ion? So bila kita draw dia punya Lewis structure, okay, we found that, okay, I3 minus, okay, so this one dia ada 3 pair, okay, 3 lone pair, and then 2 bonding pair, AB2 E3. So AB2 E3 is linear, so the bond angle is 180 degrees. Okay, right, so and then this one also N double bond N, okay, N double bond N, so no lone pair for the central atom, So this one is AB2. So kalau AB2 it is a linear structure. Linear also have the bond angle 180 degrees. Both ion are trigonal planar. So salah. Both ion are sp hybridization. Wrong. Okay. The bond angle between the bonds are 180 degrees. Yes, this one is correct. Both ion have 2 electron pairs arrangement. Okay. 2 electron pairs salah lah. Okay. So the most correct answer is option number 3. Next, question number 15. Which of the following species has a value of dipole moment equal to 0? For equal to 0 meaning that dia adalah non-polar. Okay. Dia kalau dia non-polar, okay, kita tengok. Okay, dia tiada cancellation. Dia berlaku cancellation. Okay, alright. So this one no cancellation. Okay, dia tak ada cancellation. Then this one untuk B, option B. Okay, so dia square planar. Okay, and then C. Okay, for C, moment is not equal to 0 because this one T shape. Okay, and this one is V shape. Jadi yang paling tepat adalah option yang ke B. Okay, alright. So next, phosphorus group 15 element and fluorine group 17 combine to form PF5. What is the orbital overlap to form the sigma bond in PF3? Okay, so phosphorus as a central atom, it combines with 3 fluorine. So fluorine is from p orbital, sp2 orbital and s orbital. So s orbital salah. Okay, sp2 also wrong. And then this one, the sp2 orbital salah, p orbital dah correct. sp3 orbital and s orbital pun salah because this is p orbital. And this one, sp3 orbital and p orbital. So this is the correct answer. Next, when ethyl acetate, okay, ethyl acetate is ester, mixed with ethanol, okay, and water respectively, it is observed that ethanol has lower solubility in ethyl acetate than in water. Choose a correct statement from this phenomenon. Ethanol is a polar molecule, but ethyl acetate is non-polar molecule. So this is not the answer. Ethanol is a non-polar molecule, but ethyl acetate is polar molecule. Okay, is a polar molecule. So betul, tapi bukan ini yang menyebabkan dia stronger, lower solubility. Water can form hydrogen bond with ethanol, but ethyl acetate not. Okay, salah. Okay, ethyl acetate can form hydrogen bond with ethanol, but water molecule is not. Water can form hydrogen bond with ethanol, but ethyl acetate is not. Okay, ethyl acetate can form hydrogen bond with ethanol, but water molecule is not. Sorry, actually the answer is option yang ke 3. Okay, alright. So the answer is C. Okay, alright. Pardon my mistake. Okay. Next. Okay, period 3 comprise of sodium, magnesium and aluminium metal. Arrange these metals in order of descending boiling point. Descending means that from the highest boiling point to the lowest boiling point. So we start from aluminium, okay, magnesium, sodium. So this one also mistake for this answer mark. Okay, right. So suppose the answer is second option. Okay, next. What is the density of oxygen, okay, in gram per liter at 25 degrees Celsius and 0.987 atm? Given the relative atomic mass of oxygen is 16. Gas constant R is equal to 0.08206 liter atm per mole per Kelvin. So PV is equal to nRT. So PV is equal to N over MR, okay, mass over molar mass. then mass over volume is density, okay, then RT. So P is equal to density RT over MR. So kita jadikan MR density as the formula, okay, right. So density is equal to PMR over RT. So pressure given 0.87, okay, 987 times 32 MR for oxygen, and then over 0.08206, okay, dia punya pemalar gas, and then 298 temperature. Jadi kita dapat 1.29 gram per liter. So the answer is option yang kedua. Okay, 1.29. Next. A 2 decimeter container contains 0.15 mole of nitrogen gas and 0.2 mole of oxygen gas under a total pressure of 100 kN per meter square. Calculate the partial pressure of oxygen gas in the mixture. Jadi sekarang ni, okay, kita gunakan Dalton's law of partial pressure. Okay, partial pressure of oxygen equal to, okay, fraction times P total, which is P total given is 100 kN per meter square. Okay, and then fraction for oxygen is NO2 over NO2 plus N2, which is equal to 0.2 over 0.15 plus 0.2. So kita dapat 0.571. So ini adalah fraction untuk oxygen, mole fraction untuk oxygen. Okay, and then P total 100. Jadi 0.571 times 100. Okay, the answer is 57.14 kN per meter square. So the answer is option yang pertama. Next. Figure 3 shows the variation of vapor pressure with temperature for liquid PQ and R. Based on the graph, which of the following statement is correct? So this one is relation between pressure dan juga apa? Temperature. Okay. So graph of pressure versus the temperature. Jadi kalau kita tengok di sini, the intermolecular force between molecule P are stronger than those in Q and R. Okay, P stronger daripada Q dan juga R. Okay, which is this is wrong. Okay, intermolecular forces dia lemah. That's why at lower temperature, pressure dia is very high. So the boiling point increases in order with R, Q, P. So wrong. So dia bermula daripada yang paling tinggi adalah R, okay, Q, P dekat sini. Okay, P, Q, R. Okay. Under the same condition, R have higher kinetic energy than Q. Okay, R lebih tinggi daripada Q. Okay. Salah. Okay. Kinetic energy untuk Q lebih tinggi daripada R. So P has the highest vapor pressure because it has the weakest intermolecular force. Betul, okay? Sebab dia mempunyai weakest intermolecular force, that's why dia mempunyai highest vapor pressure. Okay? So the answer is option yang keempat. Next. Alright, so now for question 25. Okay, so yang ini adalah soalan chemical equilibrium. So pada suhu 700 Kelvin, Kp diberi adalah 4.1 eksponen negatif 3. So, if 0.1 mole of phosgene is allowed to reach equilibrium in a 2-liter vessel, what is the total pressure of the system? Jadi, dekat sekarang ni, bila dia bagi Kp, okay, dalam soalan dia bagi Kp, maksudnya, parameter seperti bilangan mole, volume dan juga temperature ni, kita perlu convert pergi pressure, okay. So, kita gunakan PV and RT. Okay, so P is equal to nRT over V. So pressure initial for COCl2 is 0.1 mole times R times 700 over 2. Okay, 2 is 2 liter. Dan kita akan dapat 2.872 1 atm. So kita buat istable. Okay, P initial, P change, P equilibrium. So COCl2, okay, produce CO plus Cl2 gas, which is initial pressure dia adalah 2.871, which is kita dah kira kat atas ni tadi. So initially CO is 0, 0, and then change is minus X plus X plus X. P at equilibrium 2.871 to 1 minus x, 0 plus x, 0 plus x, x. Okay, so di sini kita boleh solve for x. Okay, kita selesaikan untuk x, which is Kp sama dengan concentration, okay, pressure Cl2 darab partial pressure Co over partial pressure COCl2 at equilibrium, which is given by x darab x over 2.8721, okay, minus x. Okay, jadi bila Kp, okay, is equal to x square over 2.8721 minus x equal to 4.1 exponent negative 3. So bila kita expand the equation, dia akan jadi x square plus 4.1 exponent negative 3 x, okay, and then this one is 0.01177.561 equal to 0. So bila kita solve gunakan quadratic expression, okay, kita dapat x1 sama dengan 0.010648, x2 negative 0.11058. Jadi kita ambil x1. Jadi bila kita substitute ke dalam P total, okay, kita substitute nilai x dengan x ni, kita tambahkan tiga-tiga ni, so kita akan dapat, okay, 2.98 atm. Jadi the answer is option yang ketiga. Okay, so question 23. Kita ada flask yang mengandungi 0.525 mol of carbon dioxide, 1.25 mol of CF4 and 0.75 mol of COF2 at 1000 degrees Celsius. Based on the balanced chemical equation, predict in what direction will a net reaction occur to reach equilibrium. Jadi untuk dia mencapai keseimbangan, okay, dekat sini kita kena compare nilai Q dan juga Kc. Okay, jadi bila kita kira nilai Q, untuk kira nilai Q, kita kena gunakan concentration. Tapi dia bagi kat sini adalah bilangan mol. Jadi bilangan mol bagi dengan volume, okay, mol per liter. Jadi kita dapat molarity lah di sini. Okay, concentration 0.21, concentration CS4 0.5, concentration COF2 0.3. Jadi bila kita masukkan ke dalam QC, COF2 kuasa 2, because perkali di sini kuasa 2, bahagi CO2 darab CF4, kita dapat 0.3 square over 0.21 times 0.5, which is 0.857. Okay, alright. So kita compare nilai Kc dan QC. We found that nilai Kc greater than, okay, nilai Kc lebih besar daripada QC, lebih besar daripada Kc. Okay, jadi kalau nilai QC lebih besar daripada Kc, okay, okay, kita punya pacman dia akan bergerak ke sebelah kiri. Okay, bergerak ke sebelah kiri, so shift to the left. Okay, Q less than Kc, so the position equilibrium will shift to left. Okay, bergerak daripada kanan ke kiri. So kita gunakan konsep pacman. Okay, so jangan lupa untuk compare nilai Q dan juga Kc. Next, based on the reaction below, how changing the temperature would increase the amount of CO2. Okay, so daripada equation ini kita nampak delta H adalah negatif. Jadi kalau delta H negatif, maksudnya dia adalah exothermic. Exothermic heat is released. Okay, haba dibebaskan. Jadi kalau haba dibebaskan dalam equation, kita akan tambahkan dengan heat. Jadi bila kita tambah heat dekat dalam equation, kita letakkan heat sebagai produk. Okay, so what happen kalau kita increase, kita nak meningkatkan amount of CO2, meaning that kita nak kena cari equation yang akan menggerakkan, okay, position ke arah kanan. Okay, shift to the right. So decrease the temperature, kita kurangkan heat, so they shift to the right. Yes, correct. Decrease temperature, direction shift to the left. Salah. Sebab kalau dia pergi left, dia akan mengurangkan the production of carbon dioxide. Okay, increasing the temperature, direction shift to the right. Okay, kalau kita increase the temperature, meaning that we give more heat. Bila kita bagi lebih banyak heat, dia akan shift to the left. So this is wrong. Increasing temperature and direction shift to the left. Increase the temperature, shift to the left. Lagilah salah. sebab dia akan meningkatkan carbon monoxide. Sedangkan kita nak increase the amount of carbon dioxide. So the answer is the first option. Okay, decrease temperature and direction shift to the right. Okay, next. The pH of weak acid solution, okay, Ha is 4.6. If the percentage dissociation of the weak acid is 0.03%, what is the Ka value, okay, for this acid? Jadi sekarang ni kita nak kena cari dahulu. Okay, kita tengok ke sini. Kalau dia bagi pH, maksudnya kita boleh dapat concentration H+. Jadi concentration H+ kat sini adalah negative log, okay, 4.6 is equal to negative log concentration H+. Jadi kita dapat H+ sama dengan 2.5 1 eksponen negatif 5. Okay, jadi 2.5 1 eksponen negatif 5 ni merupakan nilai X, which is X ini adalah concentration H+ dan juga concentration A-. Jadi concentration H+ dan A- X darab X. Okay, and then untuk kita cari concentration at equilibrium pula. Okay, at equilibrium, okay, mula-mula kita kena gunakan C, kita kena cari C initial. C initial kita tak tahu, tapi kita tahu change kita iaitu X. Okay, X kita adalah bersamaan dengan 2.51. Jadi alpha kita tahu 0.03, kita ganti masukkan nilai alpha. X kita sama dengan 2.51, which is kita dapat daripada concentration H+ tadi. Jadi kita gantikan X kat sini. Okay, and then over C initial. Jadi C initial inilah yang kita nak cari. Okay, sebab kita nak masukkan dekat dalam expression concentration HA. Jadi kita selesaikan, kita dapat C initial sama dengan 0.083. Jadi kita ambil 0.083 ni, kita masukkan dekat dalam expression yang di bawah ni. Okay, HA 0.0837 tolak X. Okay, X tadi 2.51 eksponen negatif 5. Dan solve for Ka, kita dapat Ka sama dengan 7.5 eksponen negatif 9. Okay, jadi jawapan dia adalah option yang ketiga, okay, ataupun C. Okay, you can repeat this explanation kalau you tak faham. Okay, kita tengok question 29 ataupun 26 lah. Okay, 1 liter buffer solution is prepared by mixing 0.075 molar of ammonium chloride with 0.05 molar of ammonia. Calculate the pH when the 1 milliliter of 1 molar HCl is added to the buffer solution. Assume that the volume of solution does not change when HCl is added. Okay, so ini kita akan gunakan, okay, the change in pH, okay, bila kita masukkan buffers, kita masukkan HCl. Jadi ini merupakan basic buffer solution. Okay, this is basic buffer solution, which is kita campurkan weak acid, weak base dengan, okay, NH4+, okay, ammonium chloride. Jadi ini adalah kita punya salt, ini adalah kita punya weak base. Okay, jadi ammonia plus H+. Kenapa kita ambil ammonia? Sebab bila kita masukkan HCl, HCl adalah acid. Jadi acid akan bertindak balas dengan weak base. Jadi acid dengan weak base kita dapat ammonium NH4+, which is 0.05 tambah 0.001 produce 0.075. Okay, so this one, and initial ini kita ambil daripada ini saja. Okay, which is ammonia 0.05. Okay, H+ ini, okay, H+ ni macam mana kita dapat? Kita gunakan MV over 1000. Okay, bilangan mol dia, molarity darab volume divided by 1000. So kita dapat 0.001. Okay, so NH4+ ini daripada atas ni lah. Okay, 0.075 molar, sebab 1 liter jadi mol dia pun 0.075. Jadi yang paling sedikit adalah H+. Jadi kita minus 0.001 minus 0.001 plus 0.001. So at the end of the equation, yang ini dia akan jadi 0.0760, 0.049. So kita boleh kira POH. Okay, PKB negative log 1.8 exponent negative 5. Log concentration, this one is concentration NH4+, salt over weak base ammonia. Okay, so bila kita substitute the value, kita akan dapat POH 4.93. Jadi ini adalah POH. Kita nak cari pH. Okay. 14 tolak. Okay. 14 tolak POH. So kita dapat 9.06. Which is the answer ke sini adalah option yang pertama. Okay. Alright. So this is basic buffer solution. Basic buffer solution kita gunakan ammonia dan ammonium chloride. Okay. Boleh repeat kalau nak tahu faham soalan ni. Okay, tengok. The next question 27. The solubility of Ag2CrO4 is X molar. What is the solubility product of Ag2CrO4? So, Ag2CrO4 disosiat kepada 2Ag plus dan juga CrO4 minus. Okay, CrO4 to minus. This one is CrO4 to minus, sorry Pardon my mistake. Okay, so 2x darab x. Jadi 2x kuasa 2 darab x. 2x kuasa 2 4x square. 4x square times x is 4x cube. Okay. Alright, so the answer is option yang ketiga. Okay, number 31. Which of the following is obtained when 500 ml of 0.2 molar Hgcl2 solution is added to 500 ml of 0.1 molar CaCO3, which is dia produce magnesium carbonate. Magnesium carbonate, KSP dia sama dengan 1 eksponen negatif 5. Kali ini pun kita akan compare Q dan juga K. Okay. Alright. So, mula-mula kita kena kira concentration Mg. Okay. Concentration Mg. MV over 1000. Okay. MV over 1000. Dapat bilangan mol. And then kita bahagi dengan volume yang baru. Volume yang baru adalah 500 tambah 500 menjadi 1 liter. Okay. Which is kita dapat 0.1 molar. Okay. Untuk CO3 to minus pun sama. MV over 1000. Okay. Divide by 1 liter juga. So, kita dapat 0.05 molar. Ini 0.1, ini 0.05. So, kita masukkan dekat dalam QSP. Okay. Concentration Mg to plus 0.1. Concentration Mg CO3 to minus 0.05. Jadi kita substitute je, kita dapat 5 eksponen negatif 3. Jadi Q compare dengan KSP, we found that Q greater than KSP. Bila Q greater than KSP, pigment kita bergerak ke arah kiri. Jadi kalau di sebelah kiri, okay, produce unsaturated solution. Okay. Concentration of Mg2 plus ion after mixing is 1. Okay, ni salah lah. Magnesium carbonate is precipitate. Sorry this one, kalau kita tengok sebelah kiri, Mg CO3 solid, okay, produce Mg2 plus dan juga CO3 to minus aqueous. Okay, kalau dia shift to the left, maksudnya ada precipitate lah. Okay, so magnesium carbonate is precipitate. Suppose the answer is C. Right, not this one. Unsaturated. Unsaturated meaning that they shift to the right. Okay, so the answer is type. Okay, this one C. Okay. Sorry, not precipitate. Precipitate will form. Akan dapat precipitate. Okay, last question. This one is common ion effect. The solubility product of Hgcl, okay, is 1.44 exponent negative 10. Calculate the solubility of Hgcl in 1 liter KCl. Okay, jadi dekat sini kita gunakan Hgcl produce Ag plus dan juga Cl minus. Okay, so this one initial change at equilibrium. Okay, concentration kita gunakan ice table. So 0 plus S 0.1. Initially kita dah ada KCl 0.1. Okay, 0.1 mol. So 0.1 plus S, 0 plus S, jadi 0.1 plus S. Okay, so since KSP is too small, 0.1 plus S is almost S. Okay, sorry, 0.1 plus S is almost 0.1. So S is too small. Okay, Jadi bila kita masukkan dekat dalam KSP 1.44 exponent negative 10 equal to 0.1 darab S. Okay, jadi S is equal to, okay, ini kita bahagi, dia jadi 1.44 exponent negative 9. Jadi the answer is option yang ketiga. Okay, so that's all for our discussion for revision 4. Thank you class.